All right. So I think my talk is going to be short. So I won't keep you too long. I'm the last talk before lunch. And despite this really vague title, I'm actually just going to focus on ENSO and its role in drought in the American West, since I knew that Michael would be talking about it. But he focused on annual, so I'm going to focus on multi-year timescales, just so I thought it would be complementary. Yes, and I'd like to acknowledge collaborators, Jason Smear, Ned Cook, and Ben Cook at Lamont, and my occasional sparring partners, Mark Kane and Alexi Kaplan. And it really is sparring, but we're friends after, just not during. All right, so previous hydroclimate reconstructions that have been done, just to give a little context, there have been single indices of drought, so the drought atlases by Ed Cook. There have been qualitative and quantitative, just single proxy reconstructions or single kind of areas, say stream flow at a particular stream or a particular region. There are a lot of those. But there haven't been, until kind of Michael and I do ours, reconstructions of hydroclimate along with associated climate dynamics. So what I'll be presenting here are some methodological tests, so pseudoproxy experiments, as well as some real proxy reconstructions of hydroclimate, and just focusing on ENSO actually for today. And so just to explain a little bit about pseudoproxy experiments, if you aren't familiar, the idea is that you have a GCM simulation, and you generate some proxies. You have a particular proxy network, and you generate some synthetic proxies that mimic the real-world availability of proxies as well as their behavior. And you're going to create these at these kind of typical locations. And the idea is that you're performing these reconstructions completely within the model world. So the nice thing about this, even though it is just a model, is that the experiments are controlled. You know what the answer is. You know what the errors are. So you eliminate a lot of the uncertainty that goes into traditional reconstructions. So again, the whole idea of doing the pseudoproxy stuff at the first step here is to ask the question, is it even reasonable to be doing hydroclimate reconstructions in the first place? And what type of dynamics can we reasonably reconstruct using this approach, rather than just kind of jumping in and seeing what we get? What I wanted to do was to see, okay, is this methodologically even sound to begin with? So the setup that I'll use is the CESM Last Millennium Ensemble. So for the pseudoproxy experiments, just the full forcing simulations, and I'll use 2 of them. I'm sorry, I don't think I registered this with CESM. I realized this. I need to send Sam an email or something and say, hey, I used the data. And yeah, I'm using it all over the place now. I know. All right, so basically what I did is I took 2 simulations, and for one of them, I used that as my prior. So in the data simulation equation, that's XB. You've seen kind of the equation thrown up a little bit before. I won't go into details about what it is, but the idea is that you have your initial guess, your prior from one simulation, and then I generate pseudoproxies from a different simulation. And then I'll try to reconstruct simulation 10 just based on the pseudoproxies as well as the information from my initial guess in simulation 9. So that's the setup. So I don't have an overlapping simulation, though it is the same model. So it's still CESM. And yeah, I should also say for these particular simulations, they're not highly correlated on things like El Nino, for example. They don't correlate at all in their Nino 3.4 index. Okay, so then for the pseudoproxies, what I do is grow some tree ring widths and coral delta 18O. And by this, I mean delta 18O because I'm using a forward model that doesn't require delta 18O. So just SSS and SST, and then I get delta 18O. And then for the trees, I'm going to use VS Lite if you're familiar with that. It's an intermediate complexity model basically for trees. And going to use them at the page's locations. And so I'll just be focusing on the American Southwest for this presentation, but I also looked at Eastern Africa as well. And so I used just tree rings at the green box sites, and then corals at the stars, the orange stars. All right, and then for the reconstruction, did sea surface temperature, SST, as well as some other variables, and I'll just be focusing on SST and PDSI, Palmer Drought Severity Index, even though I did some other variables as well in this test framework. And so the idea here in the pseudoproxy experiment is that this provides an upper bound estimate of our reconstruction skill. So it's idealized. I wanted to make it as realistic as possible. For example, the parameters for the PSMs, or for my proxies, were taken from estimated on real proxy data and using observational data. So I wanted the parameters to be as accurate as possible, as realistic as possible, but it is an idealization. So it's this estimate of an upper bound. So basically, what's the best that I can do? So for the North American Southwest, this is an important region for several reasons. It has outsized impact on agriculture and people. And one nice thing is that multi-year droughts in this region tend to be relatively coherent, and they've been linked to some important dynamics, especially in the tropical Pacific. So there are already theories about what causes drought here. So I just wanted to focus on this as a test case, one of a couple test cases. So in the reconstruction, I'm just showing the mean reconstruction here of North American Southwest PDSI. And so the reconstruction is in purple, and then the truth is in black. So again, this is in the model world, so I know what the answer is. And for the highlights, what I did is in the purple highlights, that's the 5 most severe multi-year droughts in the reconstruction, and then the kind of gray are with the 5 top droughts in the truth. And so sometimes they overlap, but other times they don't. So a couple takeaways from this figure is that for the reconstruction, it's very skillful, so a correlation of 0.9. And then this other metric called the continuous rank probability skill score, which is an estimate not just of the skill of the mean, but also of the distribution. It's also very good with 0.57. So I want to say, in principle, it's possible to reconstruct drought in the American West with high skill. And I also want to note that the ranking, however, is really sensitive to where the 0-point crossings tend to be. So when do you start a drought and when do you end a drought can be really sensitive to that particular time series and those 0-point threshold crossings. And so even though I have a really high skill in the reconstruction, some of the rankings aren't necessarily reliable. So I just want to throw that out there, since some people look at drought time series and say, X drought is the most severe in the whole past 1,000 years or whatever. And I'm just pointing out, I notice in doing this that you would have to have a very skillful reconstruction in order to be able to say that confidently. So there's actually quite a bit of uncertainty in any kind of statements where we say this drought was the most severe, or even say the top 5. If you pick out maybe all 20 droughts, then there's a lot more overlap or something like that. There would be a lot more overlap, but if we're kind of talking about the very top few, then that can be dicey. Okay, so then for the reconstruction, I wanted to see if we could push it down the time scale, not just think about annual reconstructions, but actually reconstruct monthly Nino 3.4. So in the pseudoproxy experiment, what I did is reconstructed monthly Nino 3.4 index. So again, this is just taking an annual proxy and then actually reconstructing at the higher time scale. So again, very skillful. You can't really see because it's all scrunched up. So if then you take the biggest drought period in this particular simulation and just sort of stretch that out, you can see it's highly skillful. Now, again, this is the upper bound. What's the best that we can expect? So it's not surprising that we do really well, but the fact that I think what's important here is that went down to monthly resolution, and it could still work. Yeah. Just appended to the state vector. Monthly time series. Yeah. Just so then it gets updated through the covariance information. Yeah. I think so, yeah. So I wouldn't expect it to work for other things. Yeah. Yeah. It works in the real reconstructions too, you'll see. Okay, so, all right. So then if you think, okay, so let's take the top 15 droughts. We're going to rank them by severity. And we say, just very simply, what's the percent occurrence of a La Nina-like state or an El Nino-like state during the reconstruction? And so I'm showing a lot of things on this figure. Maybe we just focus on this one first. So, and the basic idea here is that for my reconstructions, the truth is the kind of filled in circles, and then I did a couple different experiments where I just used trees, and then another one where I used trees and corals. But basically, the idea here is that during these droughts, it's more than the model average La Nina like conditions during those droughts. So La Nina and CESM, as has sort of been mentioned before, really likes to make droughts in the American Southwest. And that holds for these 15 most severe droughts. And then the other panel is basically just a box diagram showing those distributions. So that's the main takeaway here is that in CESM, that it does cause, La Nina-like conditions do cause drought in the American Southwest, or they're associated anyway, and it's pretty persistent. And I'm able to reconstruct them also with some skill too. So I'm also able to reconstruct the fact that La Ninas are more frequently occurring during these drought periods. All right, so now on to the real reconstructions. So my prior is going to, again, be the CESM last Millennium Ensemble. And so you'll notice I'm doing the data assimilation stuff, but I have my own code. I'm not using LMR code. So I was kind of at the beginning phases of the LMR, and then I've kind of moved on as a postdoc. So I'm continuing with my own approach. And so using the CESM, and then I'm going to bias correct the climate model fields, which seem to improve the reconstructions quite a bit. I'll be using the LMR proxy database, but when I mean that, I mean the extended one, the same one that Michael is using. And then a work in progress is I'm adding a bunch of the drought atlas trees from Ed Cook. So he's feeding me a bunch of additional trees that he used and is working on also in South America. So I'll be adding those in the next year and hope to have a hydroclimate reconstruction with all of those trees in the southern hemisphere. And then for the proxy system models, calling these proxy system models because they're all statistical. I did a linear fit with temperature or PDSI, whichever had the highest correlation, absolute value of the correlation. I did a lot of work getting VS Lite to work, and at the end of all of that, I realized that PDSI does better if I'm trying to reconstruct PDSI. So yeah, that was the end of my. If you think you can do better, please do better. Yeah. All right. So and then linear fit with either local SSD or if it was a delta 18L coral, then I used the Thompson bivariate fit too. It's also statistical. Except instead of using the same parameter values for all proxies, I estimated individual parameter values for each coral site. And then everything else is just linear with temperature. Okay, so then the same kind of ENKF methodology, except I'm using a different one that simultaneously reconstructs all the proxies together. This is like over 10 times faster than doing serially. So I don't know what you guys are doing with the LMR, if it's still serial, but I'm doing it all at once, and it's a lot faster. Yeah? Are you doing it all at once, or are you doing it one at a time? Okay. Okay. Yeah, it's a lot faster. Okay, great. Great. All right, and then for the reconstructions here, I'm reconstructing a bunch of stuff. I'm, again, just going to focus on PDSI and Nino 3.4 to keep the story simple. So yeah, I also just want to plug too. So you can get in a reconstruction PDSI Nino 3.4. In principle, you can get that. You don't have to use data assimilation to get that. So the key advantage of, I think, data assimilation is things like monthly Nino 3.4 or ITCZ location. I think these are really kind of value-added products. But I'm just focusing on PDSI Nino 3.4 here. So this is a comparison with two different drought atlases over the period 1500 to 2000. And so I'm just showing correlation between the North American Drought Atlas, and then there's the Mexican Drought Atlas, which include a lot more trees in Central America over Mexico, especially in the Guatemala region. And so as you can tell, the correlations are very high, as Michael pointed out before, like correlations of almost 1 over a 500-year period, which to me was pretty stunning. I was not expecting to do this well. And then you get a similar kind of result with observational products too. So it's not just like the reconstructions agreeing with themselves. And the detrendings are not the same as the drought atlases either. So I think there's a lot of kind of robustness in the fact that two very different approaches give you basically the same answer. All right, the one really important point that I wanted to make is this is what happens if you do that same thing. You do the reconstruction, it's all identical except you use the pages proxy network. And so the skill goes way down. So having the end point in mind, I think, is really important. And I think it's really great that the LMR team is going to make the LMR code available so that you can use this for your own particular purposes. Because if you want to reconstruct drought, then it's a lot better to have that proxy network than this proxy network. And so I think that's a really great thing about the LMR, making that code available so that people can use it themselves and make their own decisions about how they use it. Okay, so now this is reconstruction of Nino 3.4 over the observational interval. And so just to piggyback on the discussion that we had right before my talk is that we calibrate the PSMs over a particular interval. And I think LMR is mostly doing it all over the whole time period. And I wanted to do a split calibration verification interval. And so I've just calibrated over that period where we have the red box, and then computed skill over the period where I didn't do the calibration over. So your eye, so this is a monthly reconstruction. So your eye kind of picks out the lower frequencies. The skill scores are computed on the monthly time scale. So the correlation is 0.5. The continuous rank probability skill score is negative, which indicates not a skillful reconstruction for that particular metric. So I don't know, mixed bag here. But if you look at, like, our eye kind of picks out the lower frequency variability, and so you compute something like coherence, see that there's quite a bit of coherence at the longer time scales. So anywhere from 2 to, say, 5, 6, 7 years, then we have correlation. No, this one is actually just, this is for the whole thing. Yeah, because otherwise, yeah, you're doing it over a tiny time period. Yeah. But I mean, if you look at it, right, there's not, it doesn't like blow up once you get out of the calibration period. So I will make a point that I have run reconstructions where I feed in noise proxies, and you can get, like, you know, reasonably good correlations if you, yeah, I mean, we can get into the details of this. And I think it's important that we at least nod to the fact that of doing something like a calibration verification, in additional to the verification statistics that we normally do when we do these data assimilation products. Okay, all right, so then here with the multi-year droughts and Nino 3.4, so what do we see? So this is a very similar figure as what I showed before, and there are a lot of these La Nina-like states during these mega droughts, but interestingly, there are a lot of times where it isn't a La Nina-like state, and particularly in these most severe, which is really intriguing, and I am diving into that right now. Like, why in the most severe droughts is La Nina-like states not corresponding with these droughts? So that's a topic that I am looking into right now. All right, so I think that's it. I'll have some conclusions. In both these pseudoproxy and real proxy experiments, it is possible to reconstruct key dynamics of hydroclimate. and in these multi-year drought associations are often associated with these La Nina-like conditions, but in the reconstructions, it's not as coherent a story as in, say, CESM in the model world. So I'm really getting something very different in the reconstructions. It's not just CESM in and CESM out. So getting something different. And that's it. Thanks very much.